So we're going to be returning to the start point. And then this, as you can see, is going to be the same as constant increase in speed. So you're constantly increasing your speed here and here, but when it levels off, you're going to be stopping your object, and when it goes down, you're actually returning back to the start point. Because if this is our origin and we go up, stop, and then go back to the same spot, we're actually going backwards to our spot. So returning to start. We have any questions on those? We all good? All right, cool. So I'm going to erase this. I'll leave my formula up there. So next one, write the formula for calculating speed. We have it on our board already, but we've been over our like little triangle way to use it. So usually you're going to be given two of the variables within the equation. So if I gave you a question, it might say a car is traveling 40 miles in 20 minutes. You're going to be given two variables for the most part. Another way to look at it is if you have trouble solving it algebraically, is to use your triangle. So if I go here, I'm going to put B, D, and T. So what happens if I'm solving for distance and I have velocity and time? What do I have to do? Multiply. So I can multiply these ones if I'm looking for distance. If I'm looking for time and I have distance over velocity, what do I do? Divide. So you're going to divide these two, and then you divide these two. So if I'm looking for velocity, I have to take distance divided by time. Cool?
Yeah.
These speed problems should be your bread and butter. It should be the area you get the most amount of points because you're given two of the variables for the most part. As long as you know how to plug it into the triangle or know how to solve it algebraically, you should really have no problems with those at all. Cool?
Yeah.
Okay, we're going to our fourth box, so it should be the top one to the right. We're going to talk about finding slope of a line. So, we're finding slope of a line. I'm going to erase this part right here. Sometimes you might see questions like this, even though it doesn't really have you finding slope. You will see some questions that involve the slope, and it will be in y equals mx plus b. So we're looking for the m, right? Does anyone remember how to solve it in algebra? So I heard rise over run. What happens if I just give you 2 points? So if I did something like this,
y2 over y1, y2 minus y1.
absolutely. So we're going to look for our slope. It's going to be m, and we're saying y2 minus y1, and then x2 minus x1. So when we have these two, right, that gives you your slope. In a distance, so if I do distance, I'm just going to put m and s, so distance and time. What do we say the slope represents? Starts with a V, ends with velocity. Velocity. So if I have this point and I find 2 points on this graph, so for example, if I took this one and I said 1, 2, and then I did up here, I did 4 and 3, what would my slope of the line be?
3.
Whoa, so look, I have my y's are right here. So I'm going to take it, first I'm going to say 3 minus 2, because y2, y1, it's going to be divided, and then I have my x's, right? So I have 4 and 1, so I'm going to take 4 minus 1. So my final answer should be 1 over what? 1 over 3. So if I had a question like this on a test, your final answer would be 1/3 what? The units are important. Meters per second. That's the important part right there. That might throw off some people, but the units are important. You need to know that if you're looking up and it's rise over run, we're looking at meters and seconds. So the first number on the top, usually looking for your meters and then seconds. Cool? But basically too, with this equation, are you guys all good on this? Can I erase this part right here? I'm gonna erase the slope area. So right here, this is where it gets a little weird, is you might have a problem that not only asks about slope, but it says, take 2 points and write an equation for the line to find velocity, or not to find velocity, to find like the origin. That's where it gets a little weird. All you really have to know is that y, this is our y-axis, this is our x-axis, all right? So if I wanted to replace these variables, my y is actually going to be my distance. You guys kind of see where it's going from here? I'm going to have equals. My slope is what?
Your velocity.
Velocity. My x is what? Time. And then my b is going to be what?
Distance.
Close. It has something to do with distance. Starts with an O, ends with
Origins.
origin. So plus my origin. Okay. There might be a question that asks you, if you're given origin and you're given the distance and velocity, can you find the time of it? You can't just use this if you know how to do it. But if it asks you for an equation, you should know that the y is always going to be the d, the m is going to be your slope or your velocity, the x will be the time, and then plus the origin. Cool. And when we have time at the end, hopefully I'll do a question that involves this kind of process of you guys flipping over the variables to the ones that it matches in the graph. That way for the test, you guys are all good to go on those. All right? I'm gonna erase this. All right. Now we're using our second equation that we should know. So we're going over acceleration. So we're on the bottom box on the left-hand side. So acceleration, it essentially is almost the same formula. So for some reason, it's represented by a lowercase a. And then we have delta t over time. Does anyone remember what the t represents?
Change.
Change. So if I put delta t, it just means change in time. So if I started at 0 and I went 10 seconds, my delta would be 13. So velocity is like the same principle. If I started at 10 meters per second and I finished at 15, what's my delta be? 5. So my change was from 10 to 5. So that's where some people are getting confused and getting the problems wrong, is I'll say a person started at 10 meters per second and they finished the race at 15 meters per second. What was the change in velocity? It would be 5. It wouldn't be 15. Okay? So this just means, basically, a delta essentially means final minus initial. Cool? So delta just means final minus initial. When you look at that too, there might be problems where, say I start a race at 15 and I finish at 10. Would my delta be